Okay, page 2. We have 4 steps when we have an equation. So these all have an equals, and we'll be solving for dy dx, okay? So step 1, we're going to differentiate both sides of the equation with respect to x, which is what we were just doing on the first page. Then we'll collect all terms involving dy dx on one side of the equation and move all the other terms to the other side. Factor out dy dx if necessary, then solve for dy dx. So at the end, you actually want to have dy over dx equals blank. Okay, you want to have this, so we're solving for it. Okay, so we're going to find dy dx, for example, 2, by doing all of these steps. All right, so differentiate both sides with respect to x. Okay, so y to the third. I'm going to differentiate. These all have pluses and minuses, so they're all separate terms, and we're differentiating separately. Okay, so this would be 3y squared dy dx with respect to x. All right? Now, y squared. That derivative ends up being positive, so plus 2y dy dx. Okay? I write a lot bigger than this types out, so stay with me. Negative 5y, that derivative would just be negative 5. There's still a y, so dy dx. Okay. Minus x squared, that would be negative 2x, and we're differentiating with respect to x. So if I put dx over dx, it would go away. So we don't need to worry about it. Equals, and so the derivative of negative 4 is 0. Derivative of a constant is 0. Okay? So I have 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x equals 0. That is all step 1. Okay? Now, step 2, I need to collect all terms with dy dx on the same side. So really, what I have to get rid of is the 2x. Okay, so I'm going to add 2x to both sides, and I'll get 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. All right, step 3, I'm going to factor out dy dx. Okay, so that will give me 3y squared plus 2y minus 5 on the left, and it still equals 2x. Okay? Now step 4, we're going to solve. So we just want to have dy dx on its own. To do that, I'm going to divide by 3y squared plus 2y minus 5 on both sides. Okay? So now this derivative of y with respect to x is equal to 2x over 3y squared plus 2y minus 5, okay? And now that's solved all the way for dy dx. That's your final answer there. Okay? And those are your 4 steps. All right, let's try a couple more. Number 2, okay. So basically you're just taking the derivative, and if you see a y, you tag on dy dx. Like, don't make it too much harder. On the right side, these are both x's, so it's just 5x to the 4th plus 12x to the 3rd. Okay, we're differentiating with respect to x, so I don't care about dx dx. On the left side, though, these are y's. They're not the same variables. So once I take the derivative, I'm going to add on dy dx. So for y to the third, that'll be 3y squared dy dx. Okay. Minus 8y dy dx. So if there's a y somewhere, it needs to have a dy dx added onto it once you take the derivative. That's really all you have to do. Okay? Now, step 1 is done. Step 2, I actually don't have to do because all of my terms with dy dx are already on the same side. That may happen. That'll be nice. Okay, so step 3, we'll factor out dy dx. So I'll get 3y squared minus 8y. Okay. So 3y squared minus 8y is what's left once I factor, equals 5x to the fourth plus 12x to the third. And so I'll divide both sides by 3y squared minus 8y for step 4. So dy dx equals 5x to the fourth plus 12x to the third over 3y squared minus 8y. That's your derivative with respect to x. Okay, number 3. So if you think you got it, why don't you pause 3 and try it and see if you get it right. Check your answer. If not, just follow along with me. Okay, so I'm going to take derivative of each term, and if there's a y there, I'm going to tag on dy dx. Okay? So for step 1, the derivative of 2y to the fourth is 8y to the third. Then I have to put on dy dx because it's y. Okay? Minus. Now this is a product rule. So what I'm going to do is put the minus and a bracket and take the product, and then I'll have to distribute that minus. Okay, so now I'm just caring about y to the third x squared. Okay, so that's a front d back. So I'll do y to the third times 2x plus back x squared d front. 3y squared dy dx. Okay, so again, that was front d back plus back d front. And that would be 3y squared, since I have a y, dy dx. Okay? All right, then moving on. I have plus 4x to the third, so that derivative is 12x squared equals, and the derivative of 5 is 0. Okay. So let's simplify this derivative before we move on to step 2. Okay, so I'm at 8y squared dy dx minus 2xy to the third plus 3x, oh, I didn't distribute that, my bad. So that would be minus 3x squared y squared dy dx plus 12x squared equals 0. Okay, now step 2, I'm going to get all of my dy dx's on one side, so we'll have to get rid of or move the other terms to the other side. Okay, so these are going to go away here, and I will get 8y squared dy dx minus 3x squared y squared dy dx equals 2xy to the third minus 12x squared. Okay? Then step 3, we're going to factor out dy dx. So I'll have dy dx times 8y squared minus 3x squared y squared Okay, equals 2xy to the third minus 12x squared. Okay, and then step 4, I'm going to divide by both sides. Divide both sides by 8y squared minus 3x squared y squared. And I will get my final answer. So 2xy to the third minus 12x squared all over 8y squared minus 3x squared y squared. That's your derivative. Okay, and for now, just don't